Hey math kids, today we're going to talk about extending the properties of exponents. So this is actually a topic that I think you last visited in 8th grade, and so you've had a full year off with thinking about exponents. So I'm going to start with just a review of what we're doing. So we have a situation like this: xa times x to the b. In this case, we are just going to add the exponents. And then a similar rule, if we do division, so xa divided by xb, then we subtract the exponents. So it's top exponent minus bottom exponent. And if we have this situation, x to the a raised to the b, then we end up with xab, like that, or multiplication of the exponents. Now the important thing on these ones is that we have the same base. And what I mean by base, in this case, the x's are the base. So we can only combine them if they're both x's, both y's, both z's, both 3's, or anything like that. We have some other. So x to the 0 is always 1. So it doesn't matter what we plug in for x. It could be 53 to the 0. That's 1. It could be p to the 0. That's still 1. So it doesn't matter what's put in there. And I think that's all we know. We're going to have to do negative exponents as well. So if x to the negative a, that means that we're on the wrong side of a fraction. Now, this is hard for a lot of kids to get the real reason or the real strategy of what we're doing. But remember, we have a ninja 1 out in front of the x and a ninja 1 on the bottom of all whole numbers, or all expressions are technically divided by 1, even though we don't write it. And so what we're actually doing is we're taking everything that's connected to the negative exponent and switching which side it's on. So if we were to do that, we'd be left with the 1 on top, still have the 1 on the bottom, and now it's x to the positive a. When we move it down to the bottom, it becomes a positive a. Now this 1 on the bottom is redundant, so we don't actually need that. So the rule is x to the negative a equals 1 over x to the a. And a lot of kids interpret that as just flipping it upside down. I don't want you to think of it that way, because sometimes you're going to have positive exponents and sometimes you're going to have negative exponents in the same problem. And if you think of it as just flipping, you might accidentally move some of them that should stay where they're at. Okay, and then just kind of the other side to that. So if we have 1, so if we have 1 over x to the negative a, that is just x to the a. Okay, now all we have to do is a few problems. And so x squared, x to the 3, and then x squared, y squared, x to the 6, y to the 5. Okay, these are two separate problems. On this first one, since it's two pieces being multiplied together, we add the exponents. So we have 2 plus 3, which gives us a 5. Over here, we need to make sure we're only combining the things that have the same base. And so we're going to have 2 and 6. So we end up with x to the 8. And now we add the y's, and so y to the 7. Okay? Now, if we're doing the division, we'll set that up. That's a 5, x to the 5 over x to the 3. okay? And the rule for this is to subtract exponents. And so this one would be x to the 1, which is redundant. That 1 is redundant. We don't need to write it, so we can just write x. Right here we get x squared, because 5 minus 3 is 2. And then 6 minus 2 is 4. So we get x squared y to the 4th. Okay. Now we'll move on to the multiplication rule. X to the 3 to the 2. X to the 2, y to the 3, and then all of that raised to the 4. So in this situation, we want to multiply exponents. So we do 2 times 3, we end up with x to the 6. This one, we want to think of it as distributing. So x squared, or the 2 times the 4, is going to be x to the 8. And then 3 times 4 is going to be 12. Okay? And we'll keep moving on. So we have 3 to the 0, 5 to the 0, and cat babies raised to the 0. Now the rule we're using is anything raised to the 0 is 1. So that means that that's 1, that's 1, and that's also 1. So it doesn't matter what it is. Anything that's raised to the 0 is 1. Okay, now we're going to move on to, let's see, which one did we do? Oh, the negative exponents. So we have 1 over x to the negative 2. And then if we have y to the 5, x to the negative 3 on the bottom. So remember what we do. We have Ninja 1. We take all the pieces that are connected to the negative exponent, switch the side of the fraction. So this one's on the bottom. Bring it to the top. So we have a 1x squared over 1. These two ones are redundant, and so we'll just write it as x squared. This one, we can just think of it as this piece needs to come up top. So y to the 5 stays on the top, but then we also have x to the 3. Okay, since everything on the bottom moved, we don't need to keep that 1 on the bottom, and so that would be the final answer. Okay, so all the stuff we've talked about so far should have been a review from 8th grade. You may be a little rusty on it, but now the new stuff's going to come.